Okay, so let's talk about Huffman's algorithm. So this is a compression algorithm, and really it's just as simple as saying it's an approach that starts at the leaves and builds the tree up from the bottom up. So let me give you an example of that. Let's set aside and ignore frequencies or probabilities for a moment, and let's just talk about how you might combine nodes into a tree and building it from the bottom up. Well, so for example, I could take all of my symbols and I can say they're all leaves. We know that they will end up all being leaves, so I can just pluck them down here and say they're all leaves. When you have multiple trees here or multiple leaves, we can just call this a forest. So here is our forest to begin with, and we want to make it so that it's compressed into a single tree. Well, maybe I can, in iteration 1, combine C and D. So what do I mean by combine C and D? Well, I'm just going to create an internal node, and the left child of that node is C, the right child is D. And then next, maybe I want to combine, maybe I'm doing this from left to right, I want to combine B with the tree C and D. Well, what does that look like? I create another internal node, and the left is B, so I've created another node, the left is B, and the right is the node that we already have in our tree. And then finally, in the fourth iteration, I am going to create a new node above these, and tie it together like that. Okay, so this was just one example. There's no reason I can't start with C and D, and then next go to A and B and combine those together, and then combine those into a single tree. So an interesting question here is, which tree is better? Well, without giving you the frequencies, there's no way to know. So it depends on the frequencies, and the frequencies sort of dictate how we will construct the binary trees. Okay, so we're building from the leaves up in our tree. So how do we know which two symbols to merge? And the easiest way to think about answering this question about which two symbols to merge is to ask yourself, how does the final encoding length of a symbol relate to the number of merges it experiences? So going back to these two pictures, how many times was D involved in a merge? And how many times was A involved in a merge over here? Luckily, the number of merges is easy to see when you look at the tree. It's the number of nodes on the path to that symbol. So D was merged twice and A was merged once. That's a 1. So each merge is going to add one more node to the path from the root to our given symbol. So how do we minimize the weighted average encoding length? So which two nodes should we choose to merge first? Well, we want to merge the two least frequent characters first. If we do the highest frequency characters first, that's going to push them further down in the tree, and that's going to increase the coding length for the high frequency characters, which we don't want. So we always do least frequent characters first.